Hi class, we're back with lesson 10, and this lesson is mostly on population density. The theme is civic life, which basically just means kind of an understanding of the world and how we fit into it and things like that. We kind of end the lesson with how votes are distributed amongst the states. But we're going to talk in this unit strictly about population density. And we start off with the question, what would we need to know in order to calculate the population density of this class? You should have already done the preview for lesson 10. If you haven't, you might want to go do that. But it asks, what do we need to know that? Well, in order to know the population density, we need to know two things. We need to know the population, and we need to know the size where that population is living. So if we were talking about the population density of the class, we would want to know how many people were in the class and how big the room was. So since we aren't actually in class, I'm going to just kind of make up some data here. So say we had a room that was 30 by 30, a classroom that was 30 by 30. That would give us a class size of 900 square feet. And then say we had a class of 21 people. So if we wanted to figure out the population density of the room, what we normally do is we talk about how many people there are per square mile. That's what we're going to do down here. And so we might do, for the classroom size, we might do 21 people per 900 square feet. Now, the only problem with this is a little weird, because if we do this, 21 divided by 900 is only 0.0233. It repeats, so we'll round it to 0.023. Well, what this means is that we have 0.023 of a person per every square foot of the room. And just as a little bit of a discussion point here, a square foot is 1 foot by 1 foot. So when somebody says a square foot, they literally mean a square that is a foot on each side. I'll use the actual letters here instead of the tick mark. Okay, so 1 foot by 1 foot is a square foot. There's a lot of floor tiles that are 1 foot by 1 foot. The larger tiles that you use in a house are typically 1 foot by 1 foot. But this is kind of weird. How do you have 0.023 of a person? That's a fraction of a person per square foot. And so sometimes what they'll do, if that doesn't make sense, if the way that you're dividing doesn't make sense, you can flip it. We could say that it's 900 square feet for 21 people. Now, if we do that, 900 divided by 21, then we get about 42.86. I'm just going to say 42.9 square feet per person. And so basically what this is saying is that each person in the room has about 43 square feet to themselves. So if we were to split that room up amongst each, so that each person had an even amount of area, then each person in the room would get close to 43 square feet. So for this, that makes sense. But when we're talking about within a country, the people within a country, we usually do it the other way around. We usually say how many people per square mile. So let's go down here and look at China versus the United States. So it says a student calculates the population densities of China and the United States. He decides that China is less dense than the United States. Use your estimation skills to decide if this is correct. So if we go up here to the top and we look at the sizes and the populations of the two countries, let's see if he's correct or if he's got some things mixed up. So here we've got the United States as being 309,975,000 people, occupying 3,717,000 square miles. For China, we have 1,339,190,000 people, occupying 3,705,000 square miles. Well, if you notice, the square miles between the two countries are actually fairly close. If you never realized that, the size of China and the size of the U.S. are actually very close to each other. And so these are very close in size, only a difference of 12,000 square miles, which when we're talking about the size of a country is not much at all. And then we look over here and we see China has 1,339,000,000 people, and the U.S. only has 309 million people. So there's no way that the density of the population in China could be less than the density of the population in the U.S. There's a much higher number of people living in approximately the same area of land in China than there is in the U.S. So he has to be wrong, because the size of the countries are similar. And population of China is much larger. Okay, so now it says they actually want us to calculate the densities per square mile of the Chinese and U.S. population. So per square mile means we want the square miles on the bottom. Per is like the divide. Okay, so per is like divide. Based on your calculation, how many times more dense is the more crowded population, which is going to be China. So for the U.S., we have 309,975,000 people for 3,717,000 square miles. So if we divide this, then we'll get how many people there are per 1 square mile. A lot of times we won't even write that 1 on the bottom. We'll just say per square mile. So again, I'm going to take that top number. When we do this division, it's always the top number divided by the bottom number. So 309,975,000 divided by 3,717,000 square miles comes out to be approximately, and I should always put approximately here, 83.4 people per square mile, which means on average, it doesn't mean all over the country. There are more dense locations and less dense locations, obviously, but on average there are 83.4 people living in every 1 square mile in the country. Again, a square mile would be an area that is 1 mile by 1 mile, which is a fairly decent size area. If you a mile, if you're a runner or you ride a bike, or even if you just drive. If you drive and you watch on your odometer for 1 mile to pass, that's a fairly decent distance. And then if you take that, both this way, and then all the area in between there, that's a pretty decent amount of space. So now if we go to China, China has 1,339,190,000 people for 3,705,000. Not sure if I said that right. 3,705,000 square miles. So if I divide that, I get 339,190,000 divided by 3,705,000. We get about 361.5 people for every square mile. Now, if the people were evenly distributed around China, that probably wouldn't be that bad. But the problem is there's pockets of very largely concentrated populations in China, and that are very, very dense and very, very crowded. So how does this compare? It says we want to know how many times bigger is the larger one than the other one. In other words, how many people in a square mile in the US would it take to make the people in a square mile in China? So we're going to take 361.5 and we're going to divide it by 83.4 to see how many times bigger the density is in China. So 361.5 divided by 83.4 comes out to be about 4.3. So China, it has about 4.3 times more or higher density. Let me change that to higher. I guess you could say it has 4.3 times more people per square mile on average, but I'll just say 4.3 times higher density. So we're going to start off here again with something that was discussed in one of the preview lessons again. It was talked about in one of the preview lessons that for someone to comfortably stand, it takes about 4 square feet. You can smash people together closer than that, but that's about the distance that you need to not be bumping into other people. And so 1 person per 4 square feet, or a quarter of a person per square foot, is kind of comfortable standing room. So what would the population density be if 1 billion people each stood on adjacent 4 by 4 foot squares? Well, before we calculate that, I'm sorry, I said 4 by 4. It's actually 2 by 2 foot squares. I was getting ahead of myself. So 2 by 2 foot square would be, again, and this isn't to size, of course, but if you had a square that was 2 feet by 2 feet, in other words, within here there would be 4 square feet. 1 foot by 1 foot, 1 foot by 1 foot, 1 foot by 1 foot, 1 foot by 1 foot. So again, if you think of the larger size typical household tile, 1 foot by 1 foot, you have 4 of those to stand in. So if all these 1 billion people stood in one of those, what would the population density be? Well, first of all, this is not 2 square feet. This is 2 foot by 2 foot, gives you 4 square feet. And so you have each of those billion people having 4 square feet. So you have, go over here and work, we have 1 billion people. And each of those people has 4 square feet. So that would be 4 billion square feet. Well, it doesn't matter that we switch this to 1 billion people and 4 billion square feet. You still have, if we cancel here, cancel zeros, you can do that only if it's zeros on the end like this. That still gives you 1 person per 4 square feet. Just because we multiplied it by 1 billion people doesn't change the fact that each person, 1 billion people each, so each person gets 2 foot by 2 foot, so that's 4 square feet. So we still have 1 person every 4 square feet. So now it says picture the billion people each standing in their adjacent 2 by 2 foot squares. Calculate the population density per square mile. Be ready to explain your reasoning after working with your group members. So if we're going to calculate how many square feet are in a square mile, that's a little bit, it's not tricky, but it's bothersome to people, because when people see that 1 square mile is 5,280 feet, they want to then assume that 1 square mile is 5,280 square feet, and it's not. So let me draw another picture to kind of illustrate this. So if you had an area that was 1 square mile, so say this is 1 square mile, that would mean that it would be 1 mile long and 1 mile wide. So 1 mile this way and 1 mile this way. Now if we wanted to switch that to feet, this would become 5,280 feet. And this would also become 5,280 feet. Well, if you remember, the way that you find an area of a square or a rectangle is you take length times width. So instead of calling this 1 square mile, hold on a second, let me erase this. Let's measure that. But remember, it's still 1 square mile because it was 1 mile by 1 mile. So how many square feet is that? Well, we have to take the 5,280 feet this way times the 5,280 feet this way. And there's actually, if you take 5,280 times 5,280, there's actually, this is a fairly large number here, see if I can squeeze it in here, 2,787,8400 square feet in this area. But remember, this was 1 square mile. It just takes, let's get this with commas so we can read it easier, 27,878,400 square feet. Again, you're talking about taking a whole square mile, 1 mile by 1 mile, and covering it essentially in those larger size housing tiles. Well, is it any wonder that it would take, if you're talking about an entire square mile, that it would take 27 million plus household tiles to cover that entire area. So it's not just 5,280, it's 5,280 squared, or 5,280 times 5,280. So now it says we want to figure out the population density per square mile. So I'm going to try to show this a couple different ways. I don't mind when you do your work how you get your calculation, as long as you're doing things that are mathematically sound and you show your work. So I'm going to show you a couple different ways we could calculate how many people this is per square mile. So if we go up here, remember this is 1 square mile. So 1 person per 4 square feet is how many people per square mile? So this is a square mile, 878,400. So remember, that's 1 square mile. And so in order to get from this to this, we have to figure out, well, what was 4 multiplied by to get 27,878,400 as a denominator. So if we take that 27,878,400 and we divide it by 4, we get 6. Let me write this down here. Slide down a little bit. So if we take 27,878,400 and we divide that by 4, we get 696,9600. So in other words, we would get 6,969,600 people per this many square feet, which again is, and I'm going to actually just change this and say about 7, this is roughly 7 million, because 6,969,600 is fairly close to 7 million. So it's about 7 million people per 1 square mile. Again, you're talking about an entire square mile and each person only getting 2 foot by 2 foot, just barely enough to stand without bumping into another person. If you filled an entire square mile like that, this is saying you could fit 7 million people in there, believe it or not, which is kind of hard to wrap your brain around, but again, they're not getting very much space. They're just getting just enough room to stand. So let me do another way of doing this. If you're not crazy about that, we could go back up here to this measurement that we had, and you could say, okay, if you've got 0.25 of a person per 1 square foot, and again, we're trying to figure out how many people that is for 27,878,400 square feet, because that's 1 mile, that's 1 square mile. Then what would we have to do? Well, this is clear what this multiplication is. 1 to get to 27,878,400, you'd have to multiply by that number. So if we take this number and multiply it by the same thing, so if we multiply it by 27,878,400, we would get that number. We have to do the same thing here. So we have to multiply by that number again. So 0.25 times 27,878,400 again gets you that 6969600 number, which we had before. So if you like this better where you don't have to divide, you can just take, get this so that you have a 1 on the bottom and then just multiply by whatever units you're going to, or not units, but number you're going to, top and bottom. But either way, you get this nearly 7 million people within that square mile. Okay, so now I've cleaned this up a little bit so we have a little bit more room to look at these next few questions. So it asks here, or it mentions here in your preview assignment, you calculated several population densities. If this campus had the same population density as Alaska, how many people would be on campus? Well, in the preview assignment, it was calculated that Alaska is, or has, a population density of about 1.2 people, so barely more than 1 person, per square mile. So every square mile in Alaska, there's only a little over 1 person. So every person in Alaska almost has their own square mile. So Lone Star Kingwood, just from a rough estimate, is about a half a mile by a half a mile. That's a very rough estimate, but I did go look at a map to kind of figure that out. Now, if we multiply that, if you have a half mile by a half mile, 0.5 times 0.5 is 0.25 square miles. Again, if you think of that, here's a square mile. Whoops, hold on a second. 1 mile by 1 mile. And Kingwood is only a half a mile by a half a mile. So a half this way and a half this way. As you can see, if we finish this off, that's a quarter of a square mile. This whole thing is a square mile, and Kingwood is only a half by a half, so it's only a quarter of a square mile. So now, what would the population density of Kingwood be if it was only as densely populated as Alaska? Well, let's again set up something to kind of help us compare that. we want to know if you had 1.2 people per 1 square mile, what would that be if you had only 0.25 square miles? Well, to get from here to here, we have to multiply by 0.25. So to get from here to here, to find out the equivalent, 1.2 times 0.25 gets us 0.3. So if our campus, and this kind of gives a good idea if you know how, hopefully even if, hopefully you've actually been to campus and have seen it, but campus would only have a third of a person living on it if it was as densely populated as Alaska. 0.3 isn't exactly a third, but it's close. 0.3 repeating is a third. So, but 3/10 of a person living on campus is all you would have if it was as sparsely, I should say, instead of densely populated as Alaska. Now it says, what about if it was as densely populated as New Jersey? Well, in the preview lesson, it was calculated that New Jersey had a population density of 1185. I'm not even gonna, it's 0.3, but I'm just going to leave that off of that. So 1,185 people roughly per square mile. So again, what would that be if we were talking about Lone Star Kingwood? Well, to get from here to here, you have to multiply by 0.25. So to get from here to here, we're going to multiply by that same number. So 1185 times 0.25 gives us 296.25. So I'm going to say roughly 296 people. Would you think, well, that's not that many? Of course, we have more people than that living on or that can fit on campus, but you're talking about living. So imagine that 296 people lived on the Kingwood campus. If you figure, this is even a little high, but say there's 4 people per family, that's like 75 families having the space of Kingwood, Lone Star Kingwood campus, as their area that they can live in. And that's not just their houses, that would be everything. That would be the hospitals, the gas stations, the grocery stores, the schools, places to work, everything. You would have to fit 75 people in the space of the Lone Star Kingwood campus, with all the things that they need to live and work and play, all within that size. So, as you can see, that would be quite a lot of people in that small amount of space. And New Jersey is fairly crowded. New Jersey is one of the most densely populated states in the country. So, again, you've got roughly 74, 75 families living within that space and having all their needs within that space. Then it says most of the world outside the United States uses the metric system, so it's often useful to make comparisons. Bangladesh has a population density of 1,127 people per square kilometer. Note, 1 kilometer is 0.62 miles. If you convert the density of Bangladesh to people per square mile, will the numerical value be larger or smaller? Explain your reasoning. I'm going to go ahead and just do it. They don't actually require that we do, but I'm going to go ahead and do it. So 1 square kilometer, again, would be 1 kilometer by 1 kilometer. I'm going to rewrite this. So over here, I don't know why my squares are so crooked. That would be 0.62 miles by 0.62 miles, because they said 1 kilometer is 0.62 miles. So if I take 0.62, the width, times 0.62, the height, I get that this is 0. I'm just going to say 0.4. It's 0.3844, so it's actually not even quite 0.4 square miles. So this is 1 square kilometer, and 1 square kilometer is about 0.4 square miles. So now we're going to do this conversion to how many, 1,127 people per square kilometer. What is that per square mile? Well, 1,127 people per square kilometer is the same as 1,127 people per 0.4 square miles. Remember, 1 square kilometer and 0.4 square miles are the same thing. So if I want to figure out what that is per 1 square mile, you can see this is going to be a bigger, we're going to get more people because this is not even a square mile. So the answer to this is, if you convert this, will the numerical value be larger or smaller? It's going to be larger, because to get from 0.4 to 1, we're going to have to multiply. So 1, and actually there's an easier way to do that. I don't need to multiply. Since I'm going to 1, I can just take 1,127 and divide it by 0.4, and that will give us, whenever we have two numbers like this, if I divide the top by the bottom, that means per 1 of whatever's on the bottom. So when I take 1,127 and I divide it by 0.4, I get 2,817.5, or if I wanted to round that, I could say 2,818 people per square mile. They'll usually tell you in the homework how they want you to round it. So Bangladesh has 2,817.5 people per square mile. Compare that to New Jersey, which is considered one of the more crowded places in the United States. Only has 296 people. Whoops, that's not right. It was 1,185 people per square mile. And Bangladesh has 2,817.5 people per square mile. So it's more than twice as crowded as New Jersey.